Assalamualaikum. Hope that everyone will be fine. In today's lecture, we will discuss about balance strain condition, and ultimately we will derive few formula which are used in design equations or in design of singly, doubly, and all types of a beam. So first we will learn the balance strain condition. We took that the failure will be balance failure. By balance failure, the steel strain and concrete strain both reach at same time at its failure strain. So by balance strain condition, there will be a strain produced in any section. Why the strain is produced? If the beam is subjected to different types of loading. If this is a beam, if it's subjected to different types of loading due to this force or different forces, the beam will deflect. Due to deflection, the strain will be produced. If the strain produced, then the stress will be produced in each fiber. In a beam, there will be different layer. Then these layer are called fiber. Then if the steel produced, then strain also produces in the beam. So we will discuss about the strain diagram, stress diagram, and we will represent these forces in different formulas. So in this we will discuss and derive few formula which are widely used in design of RCD structures. So the first we learned in last lecture too that this is a typical cross section of any type of a beam. The length from upper fiber to the lower fiber is h, denoted by h, which is called depth of a beam, and this is called web of a beam, yani width of a beam, width of a cross section of the beam. And the center of the steel, the distance from center of the steel, we provide steel also in a beam. If we zoom it, this is a beam. If we provided that there will be steel in lower fiber. In upper fiber there will be no steel. This we will assume the general diagram. We will only derive few formulas. For that we only taken the steel in lower fiber. So steel is in lower fiber, provided in lower fiber, and the area of this steel is denoted by ASB. A means area, subscript S means steel, and B means subscript B means balance for balance condition. So these all we are discussing about the balance strain or balance failure condition. In balance, both steel and concrete strain reaches at same time its ultimate or threshold value. So this means that area of a steel in balance condition, and the web is B. So the distance from the center of the steel, remember this, the center of the steel to the upper fiber is called effective depth. This is symbolically represented by D. This distance from upper fiber to the lower to the center of the steel provided in lower fiber is called effective depth. Remember, this is widely used in calculation. So this is a typical cross section of a beam having depth h, web of B, effective depth D, and the steel area is denoted by ASB, or the steel provided in balance condition. So there will be strain produced if the beam is subjected to different types of loading. Due to loading, the beam will deflect. Due to deflection, the strain will produce. The strain diagram will be in this manner. Since we learn about the assumption of ACI codes, ACI tells that the plane section before and after bending remains same. If this is a beam, if we take the cross section, or if we cut the beam in this in this point and see from this side, then the beam looks like in this manner. So in this looks in this manner. Then after deflection, since the beam is subjected to different types of loading, due to loads the beam will deflect. Due to deflection, the beam will also looks like the deflected shape will be in this manner. I will only discuss about general case. Then the deflected shape will be in this manner. The upper fiber means I am discussing about this fiber. The lower fiber will be in tension, means that this distance will reduce. This distance initially L. After bending, this distance will reduce, no matter how the smallest reduction will be. So this distance will reduce, and the lower fiber length will increase by few millimeter, you can say, right? So the upper fiber will be in compression and the lower fiber will be in tension. So I am discussing about the cross section. If we cut the section or the beam at this point, then the beam will looks like, since this is a rectangular beam, and beam looks in this manner. So if I take a section of deflected beam, then this section, if I look this section from this side, then this section also looks in this manner. This is the fundamental assumption of ACI, which says that the bending before strain before and after bending remains same. So there will be no strain. If this is initially 10 centimeter, whatever the unit is, after deflection, there this distance should be 10 centimeter or whatever the units are. So remember this, the strain will be same before and after bending, the strain will be same. So if the strain are same, then the beam deflects in this manner. The upper fiber will become in compression because the upper fiber will compressed, and the lower fiber will be in tension. So in upper fiber, the tension compression will be produced, means that the upper length will be decreases and the lower fiber will be in tension. Due to tension, why this tension is produced? Since the concrete has capacity of compressive strength, and tension is produced due to the tensile force of steel or the tensile capacity of steel. The all compression is taken by concrete and the all tension is taken by steel. This tension and compression, if the beam is in regular manner or in equilibrium, this compression and tension will be equal to zero, or the summation of these both compression and tension will be equal to zero. This is a strain diagram. So remember, this is a strain diagram, and at this point the maximum strain will be in concrete is 0.03 and denoted by epsilon U or epsilon C or EC. We can read this in this manner. So why this is 0.003? Because this is also the assumption of ACI. In last few lecture I tell about the assumption of ACI, that it will be used in every video, in every topic of RCD. So this 0.003 comes from the fundamental assumption of ACI. Why we study the fundamental assumption of ACI? Because these are used in this lecture. This is a 0.003, the compressive strain of concrete, and in lower fiber there will be concrete. Due to the concrete, the tensile strain will be produced. What will be the magnitude of this tensile strain? The magnitude of tensile strain will be equal to epsilon S is equal to yield strain of steel divided by area of modulus of elasticity. Modulus of elasticity of steel, which is 29,000 ksi, which is also the assumption of ACI. From where this comes? This comes from Hooke's law. What Hooke's law says, that the stress will be directly proportional to the strain. So I only tell you that the Hooke's law says that stress is denoted by sigma is directly proportional to the strain. So we are talking about the steel strain and steel stress. So the steel stress is denoted by Fy. Remember this, and this proportionality will be converted into equal and constant. So the constant will be E. So Hooke suggests that this constant is E, and E epsilon, the steel strain is denoted by epsilon S. So we are interested to find the epsilon S. So this E will shift in other side, so will be divided. So Fy divided by E is equal to epsilon S, the steel strain. So from Hooke's law, this value comes here. Es, or the steel strain, is also denoted by Ey is equal to yield strain, or strength of yield strength of steel divided by modulus of elasticity of steel, which is 29,000 ksi. So now we will took the distance from upper fiber to the neutral axis. What is neutral axis? Since in lower fiber there will be tension, and the upper fiber there will be compression. and the strain will be in upper fiber there will be compressive strain, and lower fiber there will be tensile force. In this depth there will be one point where the strain will be equal to 0. There will be no value of strain, so the strain will be equal to 0. If the strain equal to 0, then this point is called neutral x, and this the line passing through this point where the strain is equal to 0, then this line is called neutral axis of any type of a beam. So the line which crosses the point where the strain is equal to 0, so this point is called neutral axis. So the distance from neutral axis to the upper fiber is denoted by CB. We only assume these all values for taking the formulas for general formulas for beam which will be used in designing of a beam. So the distance from neutral axis to the upper fiber will be CB. Now I'm interested to find the distance from neutral axis to the center of the steel. So the center of the steel to the neutral axis, the distance will be d minus CB. How it comes? Since the distance from center of steel to the upper fiber is d, if I subtract d from CB, so d minus CB, I will get this distance. So this distance will be d minus CB. And if a strain is produced in a beam, then there will be stress will be produced in a beam. So remember this, if strain produces, then stress also produces, because stress depends on strain. If strain produces, then stress also produces. The actual stress distribution, the assumption says that the actual distribution of stress will be parabolic or rectangular or trapezoid. Since the actual distribution of a stress diagram will be parabolic of this beam. This beam I will discussing about, the actual distribution will be parabolic. So the distance from neutral axis to the upper fiber is CB. C is a distance and B is denoted subscript B, shows that for balance condition. In this magnitude is F'(C) means the concrete compressive strength. And lower fiber there will be steel, so steel will be in tension. If one side in compression, then other side will be in tension. The compression takes only by concrete, and the tension creates by only steel. So there will be a tensile force of a steel. So we are normally talking about the force. We convert this diagram into a simplified or simple way. So the steel will also become in tension, so the tensile force will be produced. So what will be the magnitude of this tensile force, which is given by as Fy? From where it comes? From the fundamental definition of stress. So the stress is equal to force upon area. So we are discussing about the tensile force or the steel forces. We are talking about the steel. Since there will be we provide steel, due to the presence of steel there will be force will be induced or produced in a beam. So this force will become equal to force upon area. Stress will be force upon area. So we are talking about steel, so the steel strain will be stress will be denoted by Fy, and the force is tensile in nature, so we will denote it by T. So this equation will become equal to Fy divided by Fy is equal to T upon As, means area of steel. So we are interested to find T, so shift this As into other side, so it will multiply to Fy. So T is equal to As multiplied by Fy. So from fundamental definition of stress, from this will you come, this T shows that the tensile force, Fy shows that the strength or stress, yield stress of steel. So this is very complicated to find the equivalent force of this block. So Whitney, one of the scientists, he produced this block, convert this block into this block. this parabola into this rectangular. For few assumption that he says that this depth or length will be 0.8 times of f'(c). These all values are given by Whitney, one of the scientists. He shows that this block will similar be this block, but he also assumed few value that 0.85 f'(c). This is this length of a block, and this block, the distance, the depth of this blocks will be AB, means depth, also known as depth of compression block. This is a compression block known as Whitney compression block, and the depth of this compression block is known as is denoted by AB, or A subscript B shows for balance condition. And the magnitude, what will be the magnitude of this compressive force, since there will be compression. Due to compression there will be compressive force. What will be the magnitude of this compressive force? It is given by Whitney, which is equal to the area of this block. What will be the area of this block? Volume of this block, not area. Since this is the one length and this is the depth, so multiply depth by area will be of this block will be A multiplied by 0.85 f'(c). I only find this area. For this I multiplied this 0.85 to this, but Whitney told that this will be volume of this compressive force will be equal to the volume of this block. What will be the volume of this block? I want to make a 3D view of this diagram, so this will looks like in this manner. So I want to make this diagram 3D view, three-dimensional view of this block. This block will looks like in this manner in 3D view. This distance will denoted by B, and depth is denoted by A, since A or this distance is denoted by 0.85 f'(c). From here you can see that from here only 2D is given, which is this. Only this region is given, which is 2D. I draw this 3D view, which is having a length of B. So if I want to find the volume of this cuboid, so it will be multiply this cross section to this length. So what will be the area of this cross section, which is here you can see that 0.85 multiplied by f'(c) A. So A multiplied by this length will be B, so multiply by B. So the compressive force of this whole block will be equal to 0.8 times of f'(c) AB. So you can clearly see that here this the magnitude of the equivalent force of compressive force will be 0.8 times f'(c) AB. This is a very important result of Whitney stress block. So where it can acts, where the compressive force acts, the magnitude of equivalent force acts. So the depth of a Whitney block is A, so the compressive force will act at the center of the A, or at midpoint of the depth of the compression block. So this force will act at a distance of AB, A divided by 2 from upper fiber. Remember this. These are only distances. Remember, this is only mathematical calculation, so you can easily learn and understand easily. I want to show make sure that you understand the concept from here very easily. So this force acts at distance of A by 2 from upper fiber. So the distance from center of the steel to this where the magnitude equivalent force acts is we want to find this distance. Since the overall distance is D, the center of steel to the upper fiber, the distance is D. If I only deduct this distance A by 2 from this, so I can take this, we will calculate this distance too. So this distance will be equal to D minus A by 2. Remember, this is very important result. And the other forces are X similarly, as we can discuss this. This is equivalent stress distribution diagram which is given by Whitney. Given this diagram with these values. So this is a stress diagram of this beam, its cross section of a beam. So remember, this is a compressive force, this is a tensile force, this is the distance between two forces, this is the depth of compression block, and this is the length of compressive block, and the steel strain, steel in tension. So remember these points which are now used in consideration. So now I want to find the strain diagram. So from strain diagram I want to calculate the CB, the distance. What will be the distance only considering this diagram? So it has two triangles. So by using similar triangle technique we can find these distances. Remember this, only first consider this triangle. So what will be this triangle? So the perpendicular divided by base, so CB divided by 0.003 will be equal to, now consider the second triangle, second triangle. So what second triangle shows that D minus CB means the perpendicular D minus CB divided by EY or ES. So you can see that EY. I only assume that this strain diagram. For this strain diagram we are interested to find the CB, the distance from upper fiber to the neutral axis. What will be this distance in terms of other parameters? So I only take the similar triangle technique, the strain diagram. So I only divide the length by strain, means this length by this strain of one triangle, and equal to the length, this length and this strain of other diagram, other triangle. Both are equal, since similar triangle techniques shows that, tell us about that. If we want to find the CB, so then CB will be equal to, this is the after calculation this value comes. If we calculate that CB will be equal to D minus CB divided by EY, but multiply by what? 0.003 also. This whole vector is multiplied by 0.003. So this whole vector is multiplied by 0.003, since here is also CB, here is also B. So we want to find the CB at one side and the other parameters in other side. So shift this CB, and after calculation we can, this is very simple calculation. I did not want to get in this stuff. So I am reached to the final conclusion that CB is equal to EU divided by EU plus EY into D. This is the very important result, that CB will be equal to concrete strain divided by concrete strain plus steel strain into effective depth. This is very important result. This is the equation number 1. So this will be very used in calculation. Remember this, this will not the last point. So now we will find the taken the summation of forces along x-axis equal to 0. So since the stresses, the tensile force in this manner produced and the compressive force in this manner will be produced. So summation of f of x along x-axis is equal to 0. So T minus C is equal to 0. So T is equal to C. This is the basic structure analysis. So T is equal to mean the tensile, if the both forces are in equilibrium, so both forces will be equal, or the summation of both forces will be equal to 0. So both forces are equal, the tensile will be equal to the compressive force. The tensile force is equal to ASFY, as we seen in a few minutes before, and compressive force of concrete is 0.85 F AB, since the Whitney tells this. So both are equal. I want to find the reinforcement ratio, or for balance condition. So divide by BDFY, this equation, divide by this equation by BDFY. What is the reinforcement ratio? Reinforcement ratio is the area of steel divided by effective depth. Area of steel divided by effective depth. Effective depth is BD. This shows that reinforcement ratio. For balance, for any type of condition, reinforcement ratio is denoted by rho, symbol rho, and this is equal to the definition of reinforcement ratio is the area of steel divided by the effective area. So I want to find the reinforcement ratio. So this equation, the whole equation is divided by BDFY. So I want it is only divided by BDFY, the whole equation. So few terms will be cancelled. What terms will be cancelled? Since AS divided by BD will be equal to rho. So in place of this I put this value rho B, means reinforcement ratio. So Fy will be cancelled. So Fy will be cancelled. As divided by Bd remains. So As divided by Bd will be equal to this term, rho, reinforcement ratio. So in 0.85 remains same, F dead C. And now you only B and B will be cancelled. So one thing remains, A. What is A? A is the depth of compression block, and also we know that the A will be equal to beta. Beta is a term or a constant, and CB. We know this also. This is a basic formula, that A, depth of compression block, is equal to the beta times of distance CB. What is this? This is the distance from upper fiber to the neutral axis. So in place of A, put this value. So in place of A, we put this value, beta 1 CB. So now put this the value of CB. Now put equation 1. So in equation 1 we know that CB is equal to EU divided by EU plus EY into D. So put in place of CB this value. So if we put this value, then D in numerator and denominator will cancel out. So what remains? Rho B, reinforcement ratio, will be equal to 0.8 times of beta 1 F dead C divided by Fy, and in place of CB, EU divided by EY plus EY, and D will be cancelled. So the final equation of reinforcement ratio is this. Remember this. This is the reinforcement ratio for balance condition, and this is the basic definition of reinforcement ratio. Now we can take that what will be the value of beta. Remember, these all formulas, these will be used in every problem, design problem. So what will be the value of beta? So we know that the beta, but we did not know the value of beta. Beta value will be here is given that for F dash C less than and greater than, less than and equal to 4000 psi. If the compressive force is equal to or less than 4000 psi or 4 psi, then the value of beta will be taken as 0.85. This is constant which is provided by ACI, American Concrete Institute code. If the steel strain is greater than 4000 psi, if the concrete compressive strength is greater than 4000 psi, then the after each 100 increment of 1000 psi, the beta value will be equal to 0.05 increase, means reduce will be reduced. If the concrete compressive strength is 5000 psi, less than or equal to 5000 psi but greater than 4000 psi, so the beta value will be taken as 0.80, means 0.85 minus 0.005 minus 0.05. If the beta value is greater than 5000 psi and less than 6000 psi, so the beta value will be taken as 0.75, and for 7000 it will be taken as 0.70. By if we did not remember this, so remember this equation. By putting the value of compressive strength of concrete, we can find the value of beta. These will be used in any types of beam. So what ACI shows a few assumptions that the steel will be in this range, minimum range, maximum range. So the steel will be provided the range between minimum and maximum. So now we will deal about the maximum. What will be the formula for maximum reinforcement ratio? So the maximum reinforcement ratio will be 0. So this is the above equation as we derived that the rho max is equal to 0.85 beta F dash C Fy EU divided by EY plus ET. So this is only for taken example, so I not consider this. So I only consider this in question. We clearly knows and understand what will be the maximum reinforcement ratio. So YT here, YT is taken, not EY is taken. So YT is YT is the steel strain which is taken as 0.004. Remember, this is the minimum net tensile strain of steel, minimum net tensile strain of steel. 0.004. So remember, this formula also used in calculation for calculating the range. And now we will took the minimum reinforcement ratio. What will be the minimum reinforcement ratio? For this we know that two formulas that for minimum reinforcement ratio. If there is no need of steel, then we can also provide a steel in a beam. If there is no moment or any dangerous, if we did not provide steel, but we make sure according to SI we can provide minimum amount of steel too. If there is no requirement, so we can also provide the steel too. For the minimum requirement of steel, there will be two formulas. AS minimum will be equal to 3 times of square root of F dash C divided by Fy. This is the in terms of area. BD is greater than or equal to 200 divided by Fy BD. B is the effective depth and D is the B is the web and D is the effective depth. This is in terms of area, but in terms of reinforcement ratio, the equation will be in this manner: 3 times of square root of dash C divided by Fy is greater than or equal to 200 divided by Fy. In this we will put the value. If anyone gives the maximum value, so we can take this maximum value as minimum reinforcement ratio or minimum area. Remember, this is the very important point of minimum area. So in this topic we will learn about a few formulas. So what is the distance from neutral axis to the upper fiber? Number first, this we learn, we derive this formula. And number second, we know that what is the maximum reinforcement. We only deal with the reinforcement, derive the reinforcement ratio. For reinforcement ratio we derive a formula, and for maximum reinforcement ratio we derive took the same formula for maximum reinforcement ratio. And for minimum reinforcement ratio there will be two formulas as given here. Two formulas, number one this, number two this, in terms of area and in terms of reinforcement ratio. Which formula give the maximum value we can take as it's a minimum reinforcement ratio, minimum reinforcement area, both you can say that in terms you can say that both in this formula F dash C and Fy are in PSI. Remember this also used in calculation. So here for till here we done a very important concept for deriving few formulas which are used in widely used. Remember, this is widely used in calculation. So take care of yourself. So remember these formulas for designing of a beam. So in next lecture we will learn more about. So stay tuned. Take care. Allah.